The opinions expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and freedomslips.com, its staff, or affiliates. You're listening to Revolution Radio, freedomslips.com, 100% listener-supported radio, and now we return you to your host.
Welcome back, ladies and gentlemen, to another edition of Cosmic Catastrophe on Revolution.radio. I am your host, Diamond from the Oppenheimer Ranch Project, and joining me today is my lovely partner and co-host, Leah Shaper.
Hello.
Welcome. We've got a great show today. We're going to be talking about several topics, but they're all related to Earth's temperature. That's interesting.
Mm-hmm.
So if you didn't know, for most of Earth's history, it was about 10 degrees C warmer than today, and we'll get into the graphs, and we'll show you all of that. Another topic we'll be hitting is the AMOC. We did a show expressing the idea that the AMOC may be shutting down in a century based on climate models, and now a new paper coming out that studies the Florida current is suggesting that the AMOC is fine, and that it is not shutting down. So we'll get into that topic. What?
I'm just laughing.
And the final, we'll spend most of the time on the Great Dying, which is the Permian mass extinction. There is an article in a paper several articles in a paper that has come out saying that El Ninos, of all things, have exacerbated this Great Dying, the mass extinction at the Permian boundary. The only problem with that is there was no Pacific Ocean.
Mm-hmm.
And how do they know that El Nino is going on is there's zero confidence in that. And there's just so many problems. But the good news is that we already have things that are happening during this time that can explain the entire mass extinction. So we'll do a deep geological dive into that, which I think you'll all be, which will be very interesting. So let's jump into it. Do you have any comments before we blast off here?
Nope.
So for those of you listening in Radioland, this is replayed every night on our YouTube channel, Magnetic Reversal News. I almost forgot what?
Yeah, you almost forgot the name of the channel.
What's the name of my
Magnetic Reversal News on YouTube at 8 p.m. Mountain Time, 10 p.m. Eastern.
All right. Can you see the screen? Am I sharing?
I can.
So this is coming from all places. Well, the Washington Post, a key ocean current is holding strong despite a predicted slowdown. Scientists monitored the Florida current, which flows swiftly from the Gulf of Mexico into the North Atlantic. And they say, well, the last 40 years of observation using a cable. So there's a cable that runs from West Palm Beach to Grand Bahama Island. And using this, I think it's a transmission cable, they were able to determine the flow of water.
Yeah, what they're doing is they're using the voltage on the cable to monitor the volume of water that's coming through on the Florida current.
Now, if you didn't know, in oceanic terms, a volume of moving water there is a unit used called a sverdrup. Yes, and a sverdrup is just equal to 1 million cubic meters per second.
Not to be confused with the sievert, which is an electromagnetic unit.
Yeah, it's a measurement of electricity.
I was a little confused about that for a minute myself.
Yeah, so a sverdrup is just a measure of water. One sverdrup equals 1 million cubic meters per second. And what this cable is showing is that the flow here in this portion of the AMOC, which is called the Florida current, is 32 million cubic feet. What is it? 34 million cubic meters per second. So
right.
that is the current.
Right.
All right. So that's the basic background of the study. What did they find? What does this graph mean?
Are you asking me?
Yes.
Well, it's a bit more complicated than just what did they find, but I mean, you see in this graph a very slight drop in the volume of the current over the course of about 40 years. So the question is
So that
so
would
that,
be evidence that the AMOC is slowing.
right. So what they ended up doing here was determining that it wasn't slowing nearly as much as we previously thought. Because you're using a voltage measurement for this, it is affected by the magnetic field of Earth. And apparently an adjustment for that had been made basically up until 1998, from like 1980 to 1998. There was a brief 17-month window where there were no measurements taken up until 2000.
You can see that here
But
in the middle of the graph.
right. But then the adjustment had not been made for the period 2020 to 2023. And so what was being seen previously was that from 2020 to 2023,
You mean
there were
2000?
no, I mean, oh, do I?
2000 to 2023.
Yes. Okay. So thank you for the correction. So they found in that time frame that the slope, the drop off of this current was more extreme than it had been in the past, but it turns out that that data had not been adjusted for the magnetic field changes of Earth. So they made the adjustment and found that it wasn't nearly as severe as was previously thought.
Yeah, and what's interesting in this data set is that the earlier data from 1980 to 2000 shows an increase in the flow.
Does it? Very slight one?
No, I'm just looking at the spike here going up rapidly here at the end.
Oh, I see. Yeah, right.
And if this is adjusted and this is not adjusted, why didn't they show the adjusted portion from 2000 to 2023?
Well, if you go to table 1, they do basically show that, right? So
that's down here. Okay. Where's table 1?
it should be further up towards the beginning of the article. Okay, here we go. So if you go to the top of this table, you've got the cable measurements in the first row, and then the cable measurements in the second row take account of the EMF. So you can see for different time frames what that looks like in comparison to the cable without the EMF adjustment.
Yes, I see.
So the 2000 to 23, we go from a negative trend to basically a flat trend after making the adjustment.
And so then the conclusion is that all of the anthropogenic climate models and the earlier studies claiming the AMOC was going to shut down, first of all, the issues with those studies is they're based on climate models like CMIP5 or CMIP6.
Right.
So all of this begins with a model, and the model is only as good as the information you put in. And if it's a biased model that CO2, humans cause warming, well, you're going to get a garbage result.
Yeah. I mean, I don't think in this situation there's so much, I don't think there's really a CO2 factor involved in the way these measurements were taken or
No.
But what is interesting is that they also compared, let's say, like the cable measurements to the measurements that you would get by ship movement, like in this current stream, right? Which is from my reading, and maybe I'm not quite reading it correctly, but from my reading, they do mention that some of these measurements from ships might be a little bit biased because they may not be taking those measurements like on bad weather days, right? Like they're making them on good weather days. So that could affect the bottom line. But they found, somewhat significant differences between what ships have been measuring and what this cable was measuring, which sort of then confirmed that the adjustment that they made for the magnetic field of Earth was particularly important because once they did that, the measurements lined up better.
So the good news is the AMOC is not going to shut down and we're all going to be safe.
Well, that's not necessarily true either. So here's the thing, and they do acknowledge this in this paper, but there's a difference between looking at the AMOC on, let's say, like a centennial scale versus a, let's say, decadal scale. And so the only data we have here is we have a snapshot of 40 years. And actually, if you go to figure 7, which is another graph, it does a pretty good job of showing the difference between the data with the electromagnetic, magnetic field adjustment and without. Yeah, right here. So the red line is corrected for magnetic field and the blue line is not. So there is still a decrease. It's,
This is too short of a data set.
right.
Because if you were, let's say, a global warmist and you just wanted to show no change, you start the data in 2010 and it's flat.
Yeah. Right. Right.
And plus, also what you're going to see here is this is like a biannual cycle.
Well, there's also, to me, it looks like there's even like a solar cycle maybe in here because look, we're getting a minimum in 20
cycle here, right?
Say that again.
This appears to be a decadal cycle, these two humps.
Yes, yes.
So that would be a solar cycle, which is lining up with the solar cycles, 2010.
It is still too short of a data set to make that determination. But
you couldn't determine if the AMOC was shutting down with this limited data.
So here's the problem that I have, right? I'm just going to read these 2 sentences here from this paper. They say it is interesting to note that using the revised Florida current transports, the second maximum in the AMOC time series observed in 2018 becomes much closer to high transports in 2005 to 2006. To me, again, this points to an interdecadal oscillation, which they acknowledge, and maybe the solar cycle. These findings provide stronger support for the previously made conclusion that the observed AMOC time series at negative 26.5 degrees north showcases an interdecadal variability rather than a long-term decline. You can't make that conclusion either. You don't know what the long-term trend is because you haven't looked at that.
What you can conclude only from this is quite amazing, that the Florida current is highly variable. From 2006 to 2010, there was a change from 20, what is it called? Sverdrups?
Sverdrups.
20 Sverdrups, all the way down to 13 Sverdrups. That is almost a 30% decline. I mean, if 0 is no flow, that is a huge variability. And the fact that it hasn't even returned to 13 since 2010, I mean, is strong evidence that there is no decline and that there is simply variability.
Well, that could also easily be the case, right?
Yeah.
Like there's really not a lot of conclusions that you can draw from this because we're only looking at 40 years and, who knows what the larger pattern is.
And I had no idea that these currents were this variable. This is pretty interesting data.
Yeah.
All right. So anything else on that topic?
Yeah. So, I mean, I think it is useful information on some level, but I think you just can't draw premature conclusions, which they somewhat did in this paper.
Yeah, that's all about the funding, baby.
Oh, yeah. Well, of course it is, right? I mentioned this to you yesterday. I mean, the very first sentence of this paper says the potential weakening of the Atlantic meridional overturning circulation in response to anthropogenic forcing. Who like
they
no
had
one,
to have
no
that
one
sentence
has
because
determined
that's how they got the funding.
Right, exactly. They stuck it in there right as the first sentence to make sure they got funded. Like, so sad.
Give them some money.
It's so
all right.
It's so frustrating too because all of these papers that we're reviewing today have something similar going on where, there's a grand assumption about the contribution of human beings to this climate and it's like it's just all funding driven, it appears to be anyway.
Yes, and here's more anthropogenic global warming funding. And also another article from the WAPO. Scientists have captured Earth's climate over the last 485 million years. And here's the surprising place we stand now. The coldest time in geologic history. And then
but it's the warmest year ever.
Right. And here's the subtitle. In an effort to understand Earth past climates, uncovered a history of wild temperature shifts and offered a warning on the consequences of human-caused warming.
I mean, like...
How is Earth's geologic temperature record a warning to anthropogenic global warming. There's no connection.
Well, I mean, that ultimately, like when you go, I have to say that this paper is like hard to go through because it just, well, actually the next paper is too. It just seems like a lot of gobbledygook to me. But what I end up coming away with is like, it doesn't matter. It basically doesn't matter if we're here contributing to this because it's happening anyway without us. Right.
And
The
has
temperature record
forever.
shows that the wild swings in climate are happening regardless of human beings. So how does it create a warning for us?
Yeah, and
It's still going to happen.
We're going to be talking about some of these wild swings in a little bit here.
Yeah.
Specifically, one of the warmest times on Earth, the Permian, and there was a rapid cooling there and a mass extinction, and we'll get into that in the second half. But take a look at the general overall temperature graph through geologic time here, and you can see that what we're living in now in the Quaternary period is called Ice House Earth.
Mm-hmm.
And there have been 1, 2, 3, 4 other ice houses. These are cold times on Earth when we have ice at the poles like we do now. We've got a huge ice sheet on Greenland. We've got a huge ice sheet on Antarctica, miles thick. And this also occurred in the Mesozoic, Paleozoic, and back in time. But it's been much hotter.
Yeah.
An average of 10 degrees C. That's 18 degrees Fahrenheit warmer on Earth.
Yep.
That's a huge...
And just to make things even more confusing, this paper, I think it's this paper and not the other one, uses a third term, cold house. So it's hot in order of temperature. It's hot house, cold house, ice house, or the other way around, ice house, cold house, hot house. And they would say that we are actually in cold house rather than
because of
house.
Humans.
Probably.
Yeah. And
no, I'm sorry. That's a different paper. The other paper that we'll get to that makes that claim.
So the introduction here, there's a lot of problems with this. There's a lot of problems with a global mean surface temperature. It doesn't exist. It's a made up thing. Like the Arctic is always below freezing, but Miami isn't. So it's, how do you get an average of the Arctic and Miami? It's like impossible. You would need it doesn't make any sense. And there's different methodologies used. And there was just no way. So to go back in geologic time, you've got to use proxies.
Right, which means that what you really need is you need proxy data from like a huge number of points on the Earth, right? And they all have to be weighted the same, like they have to be the same distance apart. And like, your data is only going to be so good as the resolution, right? Like if you could get a temperature for any particular moment in time for like every singular point on Earth, that would be the most accurate. But like that's, how much, like what parts of the Earth are we actually using proxy data from, right? Is that weighted correctly? Because we have the same problem today, right? Where we're providing these estimates of global mean temperature, but they're affected by where we are recording the temperature. If we're recording temperatures on airport runways, they're going to be significantly affected by the heat there, So it's like, it doesn't make sense in any way.
So there's a huge problem with global mean surface temperature. However, whatever means they're using to determine this, the graph is revealing something.
Well, what's funny is what they actually did was they combined, wait, where is it? Let me find the right. They're combining the global mean surface temperature with, well, I think they're basically plugging it into a climate model. So, but that climate model takes into account an assumption that increase in CO2 increases temperature, which we know isn't true and has never been proven. So what the heck are we doing here? So that's the great irony, right? They use their climate models to get this data graph, and it turns out that it shows that we're living in one of the coldest times on Earth, which is hilarious.
But it's the hottest year ever.
Right. Like, what is going on here? You know, like it's so much gobbledygook that I find I have trouble even articulating it because it doesn't make sense.
Yeah, but we do know with high resolution proxy in the form of ice cores, because we can actually take out the oxygen that was on Earth and see the 01816 ratio. Those ratios are very high resolution for temperature on Earth. And because we can measure them today, and we've measured, and we have a sampling of them, very high resolution, the actual atmosphere of Earth for millions of years in these ice cores. And what we know is the temperature just in the recent past, in the last 2 million years, has fluctuated drastically.
Right.
And in a cyclic fashion, right? We have this huge 100,000-year cycle that we're currently in. About 1 million years ago, it was a 41,000-year cycle where we went from ice age to interglacial.
Yeah.
And we're just in that. We're in the end times of this interglacial, and we are going to return back to ice age conditions based on the proxy data and the temperature graphs that we know of, just based on the pattern.
Yeah. Yes. You know, but meanwhile, like we've got all of this data coming out that's completely circular. You know what I mean? Like everything is like, oh, well, we assume that temperature responds, that the control knob is CO2. So we're going to plug it into that model, you know, in order to figure out what happened. And our conclusion is that CO2 raises temperature. You know what I mean? Like all of this stuff, all of this work is totally circular. It's bizarre. Like I can't believe that we have scientists working like this, not seeing or giving a crap that their methodology is completely circular. It's bizarre.
Yeah, well, the good news is if CO2 is an effective temperature, meaning that as temperatures rise, more CO2 outgasses from the oceans.
The reverse CO2, relationship, yeah.
And if it's a reverse relationship, you're still going to get the same temperature graph if they plug it in incorrectly.
Yeah.
Yeah.
Yep.
So that's the good news, that we may actually have good data here, even though they're looking at it in oppositeville.
Right. That's a very good point, actually. Yeah. Yeah.
Because as temperature, I mean, go ahead.
I was just going to say, how is it that I mean, I'm cracking up at the fact that the Washington Post published this and that they published it with this graph, like right at the forefront.
But they had to put the little, see the vertical spike? They had to put that.
We're all burning
up, right? We're all burning up.
It's a tragedy.
And there, see, look at that. It's showing you rapid shifts in temperature. This one is, wow, 250 million years ago during the Permian.
You know, and of course they're claiming that this is a result of CO2 induced from volcanoes.
Right, and we're going to get into that in the next here.
Yeah.
So this is a great segue. Just like we said, that even if they're using a reverse, they're saying that CO2 makes it warmer. If it actually is getting warmer for a different reason, CO2 is going to rise anyway.
Yes. Well, and that's the other thing. I mean, there's like full acknowledgement. Is it this paper? I keep getting these two papers confused. I think it's the next paper, but I'll just lump it in because they're somewhat similar in terms of their assumptions. Like, you know, there's acknowledgement that there's periods of time where CO2 is 4,000 parts per million. You know, we're at about 400 right now. Yes, it's actually the other paper, the end of the Permian, right? Like you go from 400 to 800 and then way beyond to like 4,000 parts per million.
Yeah, and there's animals still running around Earth and forests, and everything's fine.
Right. I mean, was there a mass extinction? Absolutely, there was.
Oh my, there
end of the Permian, right? But life adjusts and things change, and this happens regularly without our help. Right? It does not require us to explain any of this.
Right, and it doesn't. And none of this needs CO2 or El Niños, for goodness sakes.
No.
So the articles coming out are titled "Strong El Niños Primed Earth for Mass Extinction." And this is coming from Science.
Which is now a total rag. This
Mega El
magazine
Nino
is such a rag.
Mega El Nino instigated the end Permian mass extinction. And here is the editor's summary. Here's the problem. Before we even start, where are we going? Right here. This is the time we're talking about, the late Permian, 250 million years ago. And it was the time of Gondwana, which is where all of the continents on the planet, for the most part, are connected or in close proximity.
Yeah.
And here's the kicker. Outside of the circle of Gondwana here, see the blue here, they're calling the Panthalassic Ocean.
Mm-hmm.
There is no evidence of this existing on Earth.
Mm-hmm.
There is not a single piece of the Panthalassic Ocean floor.
Right.
And it is and look how much of it is. It's
Well,
2/3 of the Earth, and there is no evidence of it. So this is the big problem.
Right. And not to mention how unbalanced this would make the Earth's, like the physics of its spinning.
So what if this area here, which we're calling Gondwana, was actually the whole surface of the Earth?
Right.
And none of that Panthalassic Ocean existed.
Right.
There was a Paleo-Tethys Ocean. We have evidence of it. We have evidence of a Tethys Ocean. We have evidence of all of these oceans, but none of this big one.
Yeah. Yeah.
So there's a big issue with plate tectonics.
Right.
And the fact that we use uniformitarianism is the problem. They're assuming that 255 million years ago, the Earth was exactly the same size and blah, blah, blah.
Mm-hmm.
Which is probably not the case.
Right.
Because there's no explanation for, right after this extinction event, why dinosaurs existed, especially as large as they are at the end of the Cretaceous. Now, if the Earth were a different size, we had different gravity, maybe the Earth was in a different position in the solar system, these could explain how dinosaurs came to be.
Right.
What's
But
interesting—
that's just too preposterous to consider.
What's interesting is I think the Earth grew rapidly at the Permian extinction.
Yeah.
Because on the edge of this fake ocean here in China, there was a huge volcanic event that lasted for tens of thousands of years, and it erupted 100 cubic kilometers, 1 million 1 million square kilometers were covered in China. And then 9 million years later, this is very close in geologic time, in Siberia, there was a basalt eruption that lasted for millions of continuous years, and it covered an area bigger than North America, up to a mile thick. And this is all happening at this quote unquote end Permian extinction, which they're going to blame on El Nino. I find that embarrassing.
Well, and the reason that they're doing that, right, it's sort of multifold, but what they did is they took this picture of Earth with Pangea, Gondwana, and they plugged it into one of their climate models. And they said, oh, look, they had something very similar to our El Nino today. So it's like, are you kidding me? Like this is, it's a completely different picture of Earth, and you're telling us that the El Nino was the same thing? Like it doesn't even—
assuming that Panthalassa, the ocean, existed, which I don't think it did, because there's no evidence of it on Earth.
Right.
If an ocean was 2/3 of the Earth, there should be a piece of it left. It was only 255 million years ago. We have pieces that are 5 billion years of Earth that are that old. Why don't we have the biggest ocean ever, a piece of that?
Yeah.
No one has an explanation. Yet they're going to claim there was El Nino happening on the west coast of Pangea. That is like this is the biggest fairy tale paper ever.
So the other part of the reason why they're trying to use El Nino to explain things is because they're kind of complaining about the fact that as far as the extinction is concerned, that this is hilarious. The marine losses occurred roughly 17,000 years before there was substantial climate warming, right? And then they also talk about the fact that the the terrestrial issues, the terrestrial extinctions preceded the marine crisis by tens or even hundreds of thousands of years. And then they're claiming that this like mega El Nino was somehow responsible for all of this. Like they're looking for an explanation for that. And they feel like, you know, the known events from that time frame, volcanic explosions, don't adequately explain the extinctions and in the time frames that they happened. And it's like, okay, well, maybe we don't have all of the information about what was going on then. You're going to use this BS El Nino explanation in an Earth that looks completely different than it does today. It's like, what are you talking about? There's so much garbage going on in here, I could barely read it. Like,
So let me tell you what's going on as a geologist, and this is what's fascinating. This is the end of the Permian, and at the very end of the Permian, in all deposits, so the extinction, the final dying is right here on this boundary. But what's interesting is that they don't understand the geology. 80% of species died off almost 10 million years before the end of the Permian. So at the end, the last 10 million years of the Permian, the Earth already had 80% of all species missing. So this is huge time frames. So if you've already eliminated 80% of the species and whatever's left is sparse and trying to find new ecological niches to survive, and another major event occurs, it's going to be easy to kill even more people, more species. And that's in fact what's happening here. So the first event, which is, I don't even know if the paper talks about this, is the Captinian mass extinction event, also known as the Guadalupian boundary or the Guadalupian event. And you can easily see it here. So this graph is showing you marine species extinction events. And you can see the end of the Permian is just to the right of this line. This is the Permian extinction boundary. This spike is all the species eliminated from the Siberian traps event, which happened right here at the Permian boundary, but they were already all dying off for 10 million years because of the first eruption happening in China.
right.
And this is called the Capitanian. Say that 5 times fast.
Yeah.
But I know it as the Guadalupian extinction event. So apparently I didn't know it had this many names. The pre-Lopangian crisis, the middle Permian extinction, or the Guadalupian Lopangian boundary mass extinction. And this is an extinction event predated the end of the Permian event, which they're blaming on El Nino, when already the whole Earth was in chaos. And these are some interesting graphs. So here, these arrows are all the mass extinctions the 5 major mass extinctions. There's really only one major mass extinction, and it's the Permian Triassic event, the one we're talking about. Take a look at that boundary.
Yeah.
This is the end of the dinosaurs up here. It's barely a glitch.
Yeah.
And that's when a giant citywide asteroid hit and fried the whole Earth. And it was only a blip as far as modern fauna. So this event was huge, and the reason is all right here. So 9 million years before the end event, in the Capitanian mass extinction, there is evidence that 90% or more of all reef production and carbonate production ceased. So either the Earth became Arctic, very cold, or something was affecting the seawater. And in fact, it's the eruption in China, which is flowing into the ocean, massive amounts of volcanic gases in the sky that cause these shallow oceans to become anoxic. There is no giant deep fake ocean that they draw, just shallow inland oceans that we have evidence of.
Deep fake ocean. I like that.
What?
Deep fake ocean. I like that.
There's no evidence. There is direct evidence that there's no oxygen for about 10 million years, or very low oxygen, because there's no carbonate production. This is a dead ocean, and that's why we have the great dying of all marine life. 80% is dying before even the end for 10 million years. So the oceans are dead.
Yeah.
And if the oceans are dead and there's no sunlight because a volcano's been erupting for 100,000 years, the animals on the earth, the land animals are going to suffer greatly.
Yeah. Like one of the things that they're mystified in this paper is like how it is that the marine and the land life were going extinct at like roughly the same time, but you just answered that question, right? They acknowledge on some level, they acknowledge what's the correct term, the deoxygenation of the ocean, but they don't account for this at all, and they say that this is all about global warming, that I think do they even refer to the Deccan traps? I can't remember, but they're claiming that it's the CO2 released by volcanic eruptions that caused massive increases in CO2 in the atmosphere and thus global warming. But in reality, like if the skies are dark for such a long period of time, that's not going to cause warming, that's going to cause cooling.
Yeah, it is. It's on the general. So there was this extreme warming in the middle of the Permian. From the beginning of the Permian, look at this. We came out of an ice age in the Carboniferous. Yeah. And it warmed up to the warmest the Earth has ever been. And then all that volcanic activity in the last 10 million years, so what we have is, this is the Guadalupean event. The first event, 10 million years before the Permian boundary, there's a mass extinction in sponges and corals, and then the carbonate production ceases. The only way you can do that is acidify the ocean and deoxygenate it. Mm-hmm. So if you've got these massive amounts of basalts flowing into the shallow oceans, that's going to do it. It's going to acidify the water. You could also pump huge amounts of sulfur dioxide, other gases, including CO2 in the atmosphere that will rain down sulfuric acid rain.
Yeah.
Which will acidify the oceans.
Yeah.
And the Siberian traps erupted for 2 million continuous years.
Right.
That's going to completely kill whatever oceans there are and lakes.
Right.
And everything on the surface, and plants are going to die.
Right. Right.
That's exactly what happened here.
Yeah, I mean, it's crazy too that they're screaming about, warming in this time frame, but like look at the early Permian. Like, do they have an explanation for that warming? It's like
carbon dioxide.
Yeah, I know. I mean, it's just like why wasn't there a mass extinction in the early Permian then? It's like what are they talking about? It's just the whole thing, again, it just reads as very circular, and we got some funding to write a paper about how CO2 affects climate. So we're going to use increased CO2 and a mega El Nino to explain, to say that it exacerbated existing conditions and caused extinctions hundreds of thousands of years before the conditions changed. I mean, that's basically what they're saying in here.
Yeah.
I don't think that came out very clearly, but
say it again.
I think the way I just explained that didn't come out very clearly, but
well, because I think mostly they're negating the evidence that they already have that can explain all this.
Right.
Right. And it's to get funding.
Yes. Yes.
But it certainly doesn't explain a mass extinction that was continuous for over 10 million years.
No,
so it was ongoing, a slow process of everything dying. If it's acid rain and volcanic eruptions continuously for millions of years, things will get progressively worse.
Yeah. Yeah.
Now, what's interesting is that lystrosaurus, a land animal, made it through all of this. The beginning of those extinctions, all the way through the end of those extinctions, all the way into the Triassic. These are some weird creatures. They were mostly herbivorous, and they probably had mouths more like turtles. So they're like a turtle mammal lizard.
Right. Well, and maybe they can eat like a really wide variety of plants, which maybe is why they survived.
At one point after this extinction, 95% of all land animals were these.
Wow.
Everywhere. What's interesting is they found them in the Chin Lee Formation, which is where I just was, where I got that petrified wood.
Mm-hmm.
So that's the time frame.
Interesting.
200 million. They went extinct about 205. But the span of this type of animal, which is called a diconodont. So it's an extinct genus of herbivorous diconodont therapsids. So these diconodont therapsids were everywhere during this extinction, and they made it, and they thrived. There was dozens of species. So this is a weird animal that fit the ecological niche of dark skies, acid rain, and they were eating pretty interesting plants at the time, plants that don't exist today.
Yeah. Yeah. Well, it's interesting too, just the geographical span of where they're living, right? Like that caption said, I can't read it now because you just put something in front of it, but it says,
sorry.
Antarctica, South Africa, China, which, either speaks to
So here's here's Pangea,
right, or a much smaller Earth, right, where most of the landmass is connected.
So this is Pangea. This is their time.
Yeah.
And all the fossils, what the hell? All the fossils are marked with an X. And you can see there's no fossils in North America, but there are other species that are not lystrosaurus. This is a specific one, but they spanned all throughout here.
Mm-hmm.
It's just the one species.
Yeah.
But this gave them evidence of plate tectonics because they're right across these boundaries, proving that South America was connected to Africa.
Mm-hmm.
I don't know if I buy that.
Right.
But I certainly don't buy the fact that the whole Earth is an ocean that there's no evidence of.
Right.
And there's so many fossils, complete fossil skeletons of these things.
Yeah.
So they had huge, robust bones.
Yeah, look at how thick and wide those leg bones are, and like the toe
look
bones.
At the feet. Look
yeah,
at the feet.
The feet are fascinating.
So they're
I bet
kind
they
of
could
like
swim with those feet.
hippopotamus, walrus, lizards.
Huh. Is there evidence that they swam?
Yeah, there's all different types of these, from like 10 inches to 12 inches long, squirrel-like, to up to 11 foot long.
Wow.
Dozens of species. Some were predators, some ate animals, some were herbivorous, some were they were like bears. So this variety would be digging up roots and tubers like a bear.
Mm-hmm.
See, that's what the feet are for.
Yeah.
Just fascinating.
It's got to be a highly adaptable genus, right? Like capable of eating all different kinds of things in order to make it through a mass extinction. Very interesting.
And they found evidence of hair in their coprolites, so they might have even been hairy lizards with walrus-like tusks. It looks like an alien.
Yeah.
All of these do.
Yeah.
So if you don't think we're aliens, we're probably aliens. There's another skeleton there.
It's really interesting to consider this in light of the problems with the Pangea hypothesis, right? Because if it's not Pangea, it means that Earth was a lot smaller at one time and expanded, which would seem to coincide with major volcanic eruptions, which makes sense. If you can imagine expanding Earth, you would imagine that there's going to be a lot of volcanic activity, especially if it's...
What type of lava comes out of the mid-ocean ridges now?
I don't know.
Basalt.
Okay.
And both of these eruptions that lasted for, that's the Siberian Traps. That's a mid-ocean ridge eruption. The only way you get that, when the mid-ocean ridge erupts, it's because the Earth is expanding through spreading. It's a divergent boundary. Mm-hmm. So what happened for 2 million years was that the Earth was expanding.
Yeah.
And when it expands, it's going to erupt basalt continuously because cracks are forming in the Earth. This is evidence of expanding Earth at the Permian extinction event.
Well, and it's a question we've asked before when we've done episodes about expanding Earth. I think we did 2 of them in the past, if you care to go check those out. But But, you know, we had a question about like, is this something that's happening on a continuous basis, or is it happening in big spurts? And it seems like, you know, especially an extinction event at this level of this magnitude would seem to suggest that, yeah, it happens in big spurts. And maybe it also happens continuously very slowly, but.
And maybe the reason that the Earth expands is when the times when our planet is changing position in the solar system.
That I have wondered, right? Like, what is the trigger? If this is happening and it's happening in spurts, what's the trigger? Because it's got to be something pretty significant, right? And there are reasons to consider that we have not always been in the same position in our solar system that we are in today. So
I mean, there's
that would
people
be
claiming that we were in a different position recently, like Velikovsky.
right, right.
He suggests a few thousand years ago, Venus and Mars were in close proximity.
Mm-hmm.
And then the Thunderbolts Project, the Saturn myth, and David Talbot, they are thinking that we were in some type of planetary alignment in a plasma sheath with a polar orientation with Mars and Venus.
And Saturn would have been at our North Pole, right?
Well, we would be at the South Pole of Saturn, and it would be, everything would be aligned.
Right. Right. So imagine if that were the case, and then something happens, like, you know, maybe Venus is a comet that flies into the system and mucks the whole thing up. I mean, the forces involved with, you know, having a sun at our North Pole and then that suddenly changing and then changing our relationship with all of these other planets, like, those are going to be pretty extreme forces that are going to dramatically affect the conditions on Earth. So that's certainly possible. I'm sure it sounds crazy to a lot of people, but
let's talk about it. See this blip here?
Yeah.
That is the end of the dinosaurs. One of the largest impact events on Earth. It would have burned the whole Earth. There would have been a molten hole in the Earth for decades just to cool it.
Yeah.
And this is all it kills on Earth.
Yeah, right. Right. Like that's so really important to think about.
Something here is 100 times more significant than the Chicxulub crater. Let that sink in.
Right. But it's all because of a mega El Nino.
That is the most hilarious thing I've ever heard of. And so if we look at the other big mass extinctions back in the Paleozoic, which spurred on the dawn of fishes, this is when the first, after this mass extinction, the first grass showed up on land.
Mm-hmm.
There was nothing growing. And then after a mass extinction, grass was on the land.
Mm-hmm.
And then just a few million years later, we've got amazing carboniferous forests. So these mass extinctions are not related to what happened here. And I think and there's no huge volcanic events happening at either of these also. So these massive million-year-old volcanic events are screaming at us that the Earth was expanding.
Yeah. Well, the other thing that's striking too is if you look at the other extinction events, the rebound out of the extinction is like, it's, you know, kind of bounces back, except for at the PT boundary here. Like it takes a long time to really bounce back up to the same level where we were at as far as the number of organism families.
Yeah, well, there was nothing on Earth. It killed everything but those weird walruses.
Yeah, yeah. Well, and this is just kind of an aside, but it is interesting to look to just at the increase in the number of families of different organisms over hundreds of millions of years here. I mean, look at the difference between, you know, the Cambrian fauna and the modern fauna. Just the volume is hugely different.
Right, and the fearmongers are saying that we're in the next mass extinction. They clearly don't know anything about geologic time, geologic history, or what a mass extinction entails.
Yeah. Yeah.
We're in a mass extinction of humanity because of the chemicals in our food. That's for damn sure.
Yeah. Yeah.
But the plants and the animals will live on long after we destroyed the planet. Trust me.
Mm-hmm. Yeah.
So what's happening at this mass extinction is these eruptions go on so long that the ocean starts producing hydrogen sulfide itself,
Mm-hmm.
which it becomes a toxic, nothing can live there. The
Right.
brachiopods die off. All of the bivalves, all of the reefs are dead. There's no carbonate production.
Yeah.
The Earth would be, man.
Yeah,
You
I mean,
think
there's mention too
536
of,
was the worst day on Earth. You should have been alive back then.
yeah, absolutely. There's mention too of deforestation, which, perhaps can be explained by, like, let's say, sulfuric acid in the atmosphere from volcanoes, right? Like, that's going to wreak major havoc with any herbivorous, any plants on Earth, Which
Yeah,
again brings us back to this creature. What is it called again? Lystrosaurus?
yeah, but that's just Lystrosaurus georgii here.
Yeah.
But it's a diconodont. The idea is why this creature survived is that it was the first warm-blooded animal.
Mm.
And even if it got cold or hot, it didn't care.
Right.
Because it was producing heat.
Yeah.
Unlike a normal lizard, which doesn't, they wouldn't do well if it all of a sudden got cold because they just freeze up there and they can't eat. If it stays cold, they just sit there and starve.
Yeah.
This guy, they think, was exothermic, creating heat, and that's why they made it.
Yeah.
And the evidence of fur in its poop, maybe it started to develop fur when it got cold.
Right.
Very fascinating. I wish I studied this like for my PhD, but I never got that.
Yeah.
Pretty, especially because there are fossils of this type of creature nearby.
Yeah. Well, and the evidence of this type of creature would be, like, as we sort of discussed, all over the place.
Yeah, it's all over the Earth. If there is a sedimentary deposit that's in this time frame, you'll be able to find these creatures. There's so many skeletons.
So interesting.
Right. And in the early days, when you found this fossil, you knew you were at the Permian extinction because they only lived before and after it.
Yeah.
So you knew you could find the extinction event if you found this guy.
So interesting. I can't believe that I've never even heard of it before.
Yeah, most people have never heard of it. It's the precursor to the dinosaur.
Yeah. Well, and the mammals apparently too.
Yep. If this guy didn't make it across, we might not be here.
Yeah. That's very significant. How is Lystrosaurus not mentioned in just sort of basic school curriculum? That seems crazy to me.
Yeah. Did you ever hear of a herbivorous diconodont therapsid?
No.
Yeah, those are the precursors to the dinosaurs, and this is just one species. And they're so significant. Which is interesting is that these guys made it past the boundary, right?
Mm-hmm.
The reason they went extinct, take a guess.
I don't know.
Well, dinosaurs began evolving after the boundary.
Mm-hmm.
And in about 10 million years, dinosaurs grew to about their size, up to 10 feet, and ate them all. Because they're fat and slow and they eat plants.
Right.
So they just got all eaten.
Yeah.
Because the ecological niche was filled by an apex predator.
Yeah.
So once the little dinosaurs ate all the herbivores, then there had to be herbivorous dinosaurs that were equally as fast. And so then we get all dinosaurs.
Yeah.
For the most part. Yeah. The only mammals that evolved shrunk down to tiny little, like rat-like, mouse type sizes.
Something that's going to escape the attention of a large carnivorous dinosaur.
Right. They're just not going to want to eat them.
It's like eating a crumb,
So maybe baby dinosaurs eat the mice, but then they grow out of it.
Right.
And that's why we made it across, because we were small. Mice can live anywhere, and we probably hid in a cave during the Chicxulub crater. The little mammals in caves made it.
Yeah. Well,
they just nibble on bones for a decade,
Yeah, I mean, just think about, the existence of small, tiny mammals like mice today. There's lots and lots and lots of other creatures who eat mice, and then you've got human beings always trying to exterminate them, but they're always here, they reproduce rapidly, they'll make it through.
Yeah, so there is the Permian extinction in real life. The largest die-off, often referred to as the Great Dying, 88% of all species were dead 10 million years before this boundary. So I don't think El Nino had anything to do with this.
No. It would have been if there was such a thing as a Noah's Ark at this time, it would have been a really big boat.
Right.
You know?
And apparently Noah's Ark was a diconodon.
Yeah. Right. Well, that's interesting. That's an interesting analogy, right? Because you have to acknowledge that the DNA of this creature has a lot to do with what we have today.
Great stuff.
Find us tonight on Magnetic Reversal News at 8 p.m. Mountain Time.